Okay. Good morning, everybody. Welcome to the ACM India monthly webinar series. And today is 21st June. And it's my privilege to introduce our speaker today, Mayank Vassar, who is a professor at IIT Jodhpur and a fellow of IEEE and IAPR. He received the prestigious Santi Swarna Jayanti Fellowship Award from Government of India, IEEE Meritorious Service Award, A.R. Krishnamurthy Faculty Research Fellowship at IIIT Delhi, and several Best Paper as well as Best Poster Awards at international conferences. In the past, he led the launch of IEEE transactions on biometrics as VP publications of the IEEE Biometrics Council. He has contributed to several national initiatives like Aadhaar, biometric standards, responsible AI, and DigiYatra, and a lot more. So, with that brief introduction, I would request Professor Mayank to take over and start the session. Yeah, the floor is yours, Professor.
Thank you, Krishna. Thank you, Venkat. Good morning, everyone. So let me just share my slide deck. Krishna, my slides are visible, right?
Yeah.
Okay, great. Yeah. So good morning, everyone. Today, I'll talk about a very interesting concept which some of us started working at the like worldwide level in the foundation model generative AI space, and I'm calling this as a control Z for generative AI. Right. So essentially, the two concepts that we'll be discussing today is essentially machine unlearning and multimodal negation. These are very important topics to ensure that we reach towards artificial general intelligence (AGI). Right. The current capabilities of AGIs are we all know, right? Means we are actually into the world of foundation models, and both kinds of models have seen huge progress, be it a clip style discriminative model or generative foundation models like DALI, ChatGPT, Grok, and many more. Right? And under the broad umbrella of foundation models, uh, we have seen significant progress in language models like LLMs have done like remarkable progress, right? Vision models are also making its ways, and I'll show you some interesting examples that we have come a very long way. Multimodal models, which actually combine vision, language, and audio all together, putting everything together. And that's where, in fact, our India AI mission is also focusing on uh, creating a multimodal foundation model for Indic languages. Right? So essentially, a huge amount of progress is happening, and I was recently in CVPR, and I could see that means almost, if not like less than 75% people, at least 75% papers were focusing on one or the other ways of doing foundation model. Right? And uh, if you're not doing foundation model, probably then you are not, it is said in the community that then you are not in the exciting phase of research. While partly I agree, partly I don't agree with that statement, but that's how engrossed we are in terms of uh, developing, using, and like touching the lives of billions of population with respect to this phase of artificial intelligence. And as you would imagine, when we talk about generative AI, it's about like how we generate new content based on prior training data, right? So at least when I was doing my PhD, my generative models were PCA, principal component analysis. Many of the young kids may not even know what the full form is, right, or what the PCA is. But for us, it was a generative model at that point of time. Over the years, we have seen significant progress in terms of autoencoders, and right now, then GANs, and right now diffusion model, and again, like in CVPR, I saw like a huge push towards autoregressive models. Right, so that's where the whole field is slowly moving in terms of the progression in generative model. And then you see these are three examples that I've put in over here, which are all generated samples. I'll just play the audio to highlight that.
After watching the IPL, she craved both poutine and bel puri, an unusual combination reflecting her multicultural background.
By the way, here, if you see, there is a small problem with the audio language still, because um, in terms of Bhelpuri, it actually used an accent which is not very Indic accent, right? But at the same time, it is like very real, like not a automated robot kind of voice anymore, right? And the third, this example, the figure that is posted over here is a very classical example of generating lifelike photographs. By the way, just a couple of years ago, this photograph was adjudged as the best photograph. And then later the creator actually declared that he would like to withdraw for that, because it's not a clicked photograph, it's a generated photograph, right? That really shows that even the judges, the human judges, could not distinguish what is real and what is not real, right? And that's where the power of generative AI is going. And this particular morning, like when I was putting up my slide deck, I thought actually I should also show what is the progress as of this morning. So this is like few. So I found this particular prompt on Midjourney, and you would see that when Midjourney video has been launched recently, and you could see how beautiful the videos actually now Midjourney can create. Um, so here is a prompt talking about a fashion model going around the Paris Eiffel Tower at the background, and then gave certain attributes to the particular prompt. Now, what I did was I took this particular prompt and updated the prompt with respect to some other variations, and I also created actually more samples now, with this time with Sora. And you could see like that the features are so beautiful, like even a novice user can also now create such videos. You don't need to be cinematic expert to generate these videos, or even like capture these videos. So here are two prompts, my modifications of the original prompt. And this is the first prompt with respect to putting red fort, Delhi, black handbag, and retro dress in the Indian context. And you could see like the autos and the small trucks and the people behind the scene, they all look very like Indian scenario. And the second example I created with respect to Jodhpur, because I'm working at IIT Jodhpur, so I thought let me actually also put a local context. And this time, in place of a retro dress, I actually changed it to a red sari. And you could see like the video is way too actually beautifully created with the Mehran Fort at the background. Right. So this is like the right now the power of generative AI, like with only few prompts, within few seconds, I could generate a 5-second video. By the way, I can also have a larger context window to generate much longer videos now. Right. So that's where we all are heading. Requires a huge amount of computational resources, and many applications can be built on top of these kinds of tools that are available. In fact, I was teaching a course on Introduction to Computer Science last semester. And in my last class, I told the students, means I taught you guys C programming as your first programming course. And I'm pretty sure by the time you would end your undergrad degree, your programming language would be mostly like prompting, and the compiler is going to be LLMs. So that's where like we all are probably heading in terms of where the industry is moving, where actually the research is moving. And after 2021, the foundation models essentially, as I said, like this is the message I gave to my students, that you write a single model for everything, prompt it, and then you do whatever you would like to do. Right? Means writing a Python script, writing a C program, even for a complex data structures problem, or even a complex operating system problems, is now actually becoming just like a few seconds job. Right? It means you don't need to be like an expert in operating system to write a big operating system code anymore. And this has actually enabled so when I was a PhD student, my advisors and my instructors in the US had actually told me two conventional wisdom for machine learning topics. Like when I was taking the course on pattern recognition and followed by another course on machine learning, I was told like, in fact, like it was kind of in my bloodstream to say that these are like sacrosanct messages, right? And first was like, if you provide bad data, you will get bad classifier, a bad model, like garbage in, garbage out. However, in the current context of foundation model generative AI space, this is no more applicable. We are all sitting in a data-centric world in terms of like providing billions of unaudited samples and let the actually model decide what is good, what is not so good. You don't need to even provide actually labeled data altogether, right? And when you are actually scraping at the internet level, when you're scraping the data at the internet level, you can't even control what is good data, what is garbage, and what is not garbage, right? And therefore, this particular conventional wisdom, which I was actually taught, is no more valid. And the second conventional wisdom, which we were even taught, even till today, I subscribe to, is like Occam's razor, like have as minimum parameters as possible, because too many parameters would lead to overfitting. However, right now we are talking about 5 billion, 7 billion, or even 300 billion and 700 billion parameter models. And so even students are doing assignment with 7 billion parameters in my foundation model course, right? So it's no more that the conventional wisdom that has been taught to us that have low parameterized or less with less parameters an SVM model or RDF model. Now we are talking about large models which can have billions of parameters, and that can fit a huge number of crazy functions, right? And still generalize, right? Means we can see like whether they're generalizing or not generalizing, but at least the claim is that means even with huge amount of parameters, they still generalize, right? And therefore, these two conventional wisdoms are no more valid. And as we are progressing, probably more and more support of not following these two conventional wisdoms will grow, right, and continue to grow. However, with this particular progress, there is a like both sides, right, positive and negative, and that's why I call this as a Gen AI paradox. So when we look at generative AI applications, there are several applications which are of the highest quality, and I hope my slides is visible and everyone is able to hear me. Okay, so when we talk about generative AI, both there are two sides for any technology for that matter, right? When be it a nuclear technology or generative AI, both there are positives and negatives, and that's why it's a paradox. And while we talk about social good applications and an ease of doing business, but at the same time, there are a lot of negatives as well. Bias, misinformation, deepfakes, we have seen. Now, slowly, the discussions around privacy and safety are also coming up. And that's where the focus of this particular webinar is today, like how actually we can minimize the negative parts of generative AI, right? As I mentioned, in the positive side, we see a lot of like creativity and productivity. The applications in gaming industry, applications in movie industry is speaking up with respect to use of generative AI applications or models and tools. It is actually democratizing access. As I said, like even you don't need to be a good programmer, you don't need to be a good photographer. You can, and you need to be as good at using these tools, and how actually you can take the best out of these particular tools. And there are many social good applications within India and abroad which are being actually right now explored and deployed, which are touching the lives of billions of population. But at the same time, there are many negative cases, or there are still many similarities. I wouldn't say negative in general, but there are many similarities. Still, this is an evolving area. If you recall, when during pandemic, when Zoom actually came up with this, like when we started using Zoom, right? So a lot of Zoom was used for different meetings, day in day out meetings. We all are working from home. Even I was teaching from home, and Zoom and many of such platforms were heavily used. And when Zoom came up with this feature about this background, blurring the background and having a virtual background, what was happening is mostly people with dark skin color, their face was also getting actually treated as background. Because at that point of time, the data that was used to train the model was essentially biased data. And that actually caused a lot of like Twitter and social media posts about that Zoom is essentially biased, right? And this was just not about Zoom. Subsequently, there are many uh, discussions about AI models which are not doing fair, including face recognition algorithms, right? And there are many potential misuses of generative AI, creating deep fakes, creating deep fonts, right? And many more. And at the same time, like having the privacy concerns with respect to how the data is being scraped and used. And that's where like we would actually highlight that researchers started talking about responsible AI. Right? It's no more like only artificial intelligence, like now it has become to RAI or responsible AI, which encapsulates multiple themes and threads within responsible AI. One can argue like means what the words and terminologies could be, but generally like we talk about explainability, dependability, privacy preserving, safety, deep fakes or misinformation, equitability, accountability, and so on and so forth. And among these, all the topics of responsible AI, there are two thematic pointers, probably which the research community could not or did not look at to a large extent. But in 2025, lot many papers and lot many research threads, and people have started talking about two very important points as unlearning and negation. And I'll explain in my slide, the subsequent slides, what is the meaning of unlearning and what is the meaning of negation, and how actually these two actually connect back to building a responsible artificial intelligence system. But so far, are there any questions? And feel free to actually type your questions in the chat window, and in every 10 minutes or 12 minutes, I can take questions.
Yeah, Professor, there is one question, Nikhil Raghav. Can we connect if the problem of, can we connect it with the problem of double descent? I'm not sure what does it here.
Double,
Double descent.
I'm not sure what is the meaning of double descent, but if Nikhil can explain double descent problem, I can try to give my views.
Okay, so on the slide previous to Janney paradox. Janney paradox. Previous to Janney paradox. So you mean, okay, so this, can we connect it with the double descent? Maybe can you please type what does it mean by double descent?
Okay, so while he is explaining that, I can continue, and then maybe the next round I can take that up. If he
Here,
has
when
not.
you talk about the problem of overfitting, okay. Yeah, maybe we will take it later.
Yeah. So probably means if you hold on to that question, I get that what you're asking, but then probably with machine learning I can explain that much better. Means hopefully that will help. Okay, so let me explain. Let me actually try to explain machine unlearning first, and with some examples also. But before I show you some visual examples, let me ask a question to all the audience over here. If there is a small kid, and the small kid goes out, let's say in the school or anywhere, like while playing with the friends in the colony, uh, he or she learns a slang word, right? You have not taught, but somehow from the environment, the kid has learned a slang word. What would you do? Would you teach the kid to forget that slang word, like to tell the kid, okay, this is not the right word to remember, slowly forget it, give the reward mechanism or have a mechanism to ensure that the kid does not, like, it goes at the back of the mind and not at the front lobe, right? Or not at the decision level, processing at the brain. Try to like ensure that the word actually goes at the back end, or just train from scratch again, like say, imagine a scenario where you can actually reset the kid's brain and say that, like, let's actually start the whole learning again, just not the slang part only, right? Means that you start from scratch again. We don't do that, right? We essentially like try to teach the kid either with a positive reward or a negative reward, right? Means we give some sort of reward to teach the kid to forget the bad habit, right? There are very like many classical examples of even in the psychiatry and psychology about how to help the kid to forget the bad trauma or the bad memory, right? So it's an unlearning of a selective part, not necessarily like retraining from scratch again, right? So this is what, like, as a humans we do almost like a day in day out. We this is how we connect back, right? And this is what the whole concept of machine unlearning is that our machine unlearning is to enable this feature of selectively forgetting a particular concept in the model space. Right. So let me actually motivate you with some examples. Hopefully that will clarify further where I'm coming from. So this is a prompt that I gave, image of an Indian house, to three very popular models, Midjourney, DALL-E, and Llama. They all have given this sample. I believe Midjourney's memory is very probably pre-independence era, where most of the houses probably was like that. In fact, many of the houses in many Indian villages may not look like this even now. Things have improved a lot in the recent years. Right, means I went to my village this particular summer, and I did not find any such village, any house. I even tried to click some photographs of houses in my village. I could not find such a house. And even the poorest of poor had like a much better, decent quality house than this. And Dalif and Lama has went on the completely other way around. Right? They created very beautiful houses, but we don't actually stay in many of us don't stay in these kinds of houses. And again, this morning when I thought, okay, let me try with the latest model in Sora. And Sora also gave something like this. This is like this particular morning's output. So what this essentially tells is that no matter what I do, right, unless until I go and change the prompt to image of an Indian house in urban setting with modern uh, planning and architecture and all that, then only I will start getting some. But if I only say image of Indian house, I get these kinds of outputs. But if I say image of a house, it would assume that I'm talking about image of a house in probably in California or somewhere, and then it generates a modern house in an urban setting and so on and so forth. Right. So this essentially shows that there is some knowledge gap between what these models know and what our expectations are. Right. Then second motivating point is about privacy concerns. I'm pretty sure you all have seen Mr. Amitabh Bachchan and Mr. Anil Kapoor has copyrighted their voice, face, and without their consent, you can't actually use their voice, images, or videos in any context or training any particular model. Right. So if you are technically, if you are actually providing their images, like downloading from web and then providing these to LLMs, that's essentially kind of a breach of their privacy, because they did not consent their data to actually go to these LLMs and get trained in some sense, right? In fact, OpenAI's recent news around using Scarlett Johansson's voice in their audio bot was also a point of concern in few months ago, right? And even Ghibli, when this whole movement around like generating Ghibli images started, a lot of concern was also actually raised with respect to artificial intelligence using a particular style without the consent of the artist, right? So there are many privacy concerns that have been raised with respect to the application and usage of the data, or copyrighted data for training the models. Another motivating example is that see when we talk about billions of parameters and billions of samples, probably trillions of tokens, what happens is that when we train the particular model, right? And so we gave, I'm taking an example of text to image generative models. If I give a text and a image pair, the model trains, right? And then we do the inferencing. What happens in this particular context is model memorizes the data itself. Here is a classical example. See the model, the stable diffusion model, which was trained on Leon A data set. When I actually give the prompts related to the data set itself, it is kind of regenerating the samples with minor modifications as if it has actually just memorized the data. So end of the day, it essentially shows that what many people actually talk about is it's a rote learning algorithm. So it has just memorized everything, right? And you could see very much connection with respect to the original sample it has been trained on. Another classical example is New York lawsuit to OpenAI, where ChatGPT generated the text which was way too close to New York Times actual text. And this is the reason why actually most of the conferences like NeurIPS and CVPR, they put actually the disclaimer that yes, you're free to use whatever model that you want to use to polish your language, but end of the day, it's your responsibility to ensure that it is not plagiarized. Because if you just simply like read it, you will get actually beautifully written text, because originally it was written beautifully by someone, a professional writer. And then if you're just like, if the model has only learned or memorized, it would just simply generate and give it back to you. And then it's your responsibility that the model has, or your paper has essentially memorized data coming from some other paper. Right? And therefore, this is a huge concern that many in the research community wants to ensure that the model should be as generalized as possible with without like just regenerating the memorized data. And finally, if we talk about making the system more generalized, it also brings in certain negative, unlearned, unwanted behaviors. For example, generative offensive content. If I go to Grok and give a prompt that generate a face image of a brutally injured person, it would generate and give me a image of a brutally injured person. I can actually just remove the word person with some other name, maybe a public figure, and I could generate the brutally injured face image of a particular known person. Right? And that is not something that even the person would like to have, right? Means it's a personal choice. And copy style content with respect to generating images in Ghibli style, or even a famous painter's style, or creating NSFW content. How to actually have parental control with respect to generating the like from ChatGPT or from Grok or many of these models. Um, Even with direct prompting or adversarial prompting, you can generate NSFW content without any actually without major problems. So how to ensure that these kinds of unwanted behavior is minimized or forgotten at some point of time, right? And that's where actually the concept of machine unlearning comes into the picture. I hope so far the motivation is clear. Are there any questions on the motivation part?
So there is one question, Professor. How does the machine unlearning help comply with the data protection laws like GDPR's right to be forgotten?
Yeah, very good question. And probably in next few slides, you'll have the answer. So just hang on. Once I actually explain the whole process, you will be able to connect and get the answer, but I'll explain it again. So let me actually explain the concept of machine unlearning a bit more. Now, how to actually achieve that, right? And then we can also see like how a GDPR or even DPDP Act also has a right to be forgotten, right to be removed clauses, and that can also be achieved, right? So when we are training a T2I model, text to image model, we are essentially providing the paired samples, right? Image of a dog and image of a dog, image of a cat, and image of a cat, and then we can generate, like once the model is trained, we can generate whatever samples that we want, right? Which follows a particular our training data distribution. Now, the concept here is of machine unlearning is that I want to forget a particular target concept or target class or target sample altogether, right? So if we say that, okay, let's forget dog, then the unlearned model should be that if I give a prompt at the time of inferencing, uh, if I say that image of a dog, I should not be able to generate image of a dog because the model does not remember anything about it. So it's a selective amnesia, right? So I will generate at the background, I'll generate trees and everything, grass and everything. But because I don't know what how a dog should look like, I should not be able to generate that. But if I say image of a cat, a separate concept, the unlearned T2I model should be able to generate the background, the grass, and the cat, because we haven't forgotten about how a cat should look like, right? And that's what broadly the concept is. Mathematically, what um, how unlearning works essentially is, so we have an entire training data set, right? So the training data set initially has content with respect to both my retain set, like I want to retain the memory, and the set which I want to forget the memory. Let's say unwanted behavior and wanted behavior, right? So now my training data set, let's say 5 billion, has all the samples, and let's say only 5 samples were there which are not wanted. So we optimize the model with respect to this particular, the entire set, retain and forgot set, and we obtain the best parameters and model is trained. Now, the task of machine learning is to get another model space, theta dash, such that my model actually has a minimum error with respect to de-retain only. So we have retained memory on the retain set, and we have selectively forgotten on the forget set, or selective amnesia on the forgotten set. But the concept here is that we don't need to train from scratch again. Like the example I gave with respect to the small kid, right? You don't want to start from scratch again. What you want essentially is that how can we figure out this theta dash without the need of retraining the model from scratch again on only retain set. So this is the whole problem statement of machine unlearning. Okay. I hope the problem statement of machine learning mathematically is clear to everyone. Are there any questions, Krishna, on this problem statement?
Yeah, Mayank. So there is one question: how to forget a dog? I think this content in this slide should answer that one.
Yeah. So how actually we do this means in the subsequent slides you will see even how we can achieve that particular part.
Yeah, without retraining, sure.
So right now the machine learning literature, it's very new in the sense that Nearest 2023 had the first machine learning challenge on not generative, discriminative models. Right. So it was essentially in the discriminative space, how to forget a particular class. And most of the algorithms at that point of time was focusing on retraining from scratch or even doing a knowledge distillation. Like when you are distilling the knowledge from a large model to small model, you forget a particular concept or a class, and then the remaining concepts will be only distilled. Right. Then later on, actually, some papers came on only fine tuning with the forgetting objectives. And then some papers came in where people said, okay, in place of saying that forgetting the dog, so don't just forget the dog, you figure out a surrogate of dog and replace it with that particular surrogate. Let's say dog can be viewed as lion, right, or tiger, right? So you are essentially shifting in the knowledge space, you're shifting the embedding from, like, removing the dog embeddings and shifting that. If someone says that image of a dog, you would start generating image of a tiger, because the model has actually shifted to that particular surrogate. But then it's actually created more confusion, at least to me. It creates more confusion in terms of if dog is a tiger, then tiger is what, right? So then it doesn't actually make too much sense in terms of surrogacy, like shifting to a surrogate. Then some papers came in with respect to parameterized efficient unlearning, and even our paper came in with respect to continual unlearning. But a more nuanced or more complicated problem comes into the picture. And this is what we proposed in the CVPR 2025. Like, we extended the whole problem statement to a more sophisticated point, that what if we want to forget a golf ball, but not want to forget tennis ball, soccer ball, ping pong, and then cricket ball or baseball or whatever. So this becomes essentially a very fine-grained problem statement, that we want to preserve a particular concept, but do not forget a particular concept and preserve all the related concepts. So it's a subclass problem in a classical machine learning sense. It's a subclass problem. So subclass, forget a particular subclass and retain all the remaining subclasses, retain the memory of all the remaining subclasses. So existing algorithms could not even undo this particular part, like how to do that. And that's what we proposed, that how we can actually achieve fine-grained unlearning, because that's where the whole objective should be. At least this is what our feeling is. So let me explain a bit in more detail. I'll try to not go into the equations and all, but still will explain this whole problem statement. So let's look at this particular target concept of Welsh Springer Spaniel. This is a particular dog breed. It's not only now dog, means we are going into the details of a dog breed also now. Right? So it's a subclass within the class dog. So if I have to forget this particular concept of Welsh Springer Spaniel, my in the memory space, I have horse, apple, cat, and golf ball, right? And then we now in the memory space, we don't have this particular dog breed altogether in terms of once we forget. So my retain set is essentially horse, apple, cat, and golf ball. Now, what if my overall data set has a related concepts like English Springer, English Setter, Sussex Spaniel, or Cocker Spaniel? These are very closely related concepts or the dog breeds of Welsh Springer Spaniel. Within the Spaniel category, these are different sub dog breeds, very close to each other, feature wise also very close to each other. The question should come, if I'm forgetting Welsh Springer Spaniel, what should happen to these other related dog breeds? If I'm forgetting German Shepherd, what should happen to Husky? Right? Because end of the day, they both actually look very similar except the coat and the color. They look very similar in terms of their ears and the nose and mouth region, right? So that's where actually we define that the forget set as essentially is a two-part the retain set essentially is a two-part set. The first part is a course set where very distinct classes or very distinct concepts of horse, apple, cat, golf ball compared to Welsh Springer Spaniel would be one particular set. The second set is fine grain, which are very closely related concept to my forget set. So if my forget set is Welsh Springer Spaniel, my fine grained retain set would be English Springer, English Setter, Sussex Spaniel, Cocker Spaniel, and so on and so forth. Right? Now, how to obtain these fine grained concepts? So suppose you have an entire training data. Let's take example of Coco data set or even Lion 5 billion data sets. From the entire training data set, you figure out, okay, which sample that you need to forget. And our target concept is essentially a particular dog subbreed, which we call it as CTAR, right? And now what we do is we take image encoder. From the entire data set, we figure out, okay, which all are essentially the concept neighborhood of this particular concept CTAR. So CTAR needs to be unlearned. We need to figure out which are the closest neighbors, as well as the other neighbors, which are our other set, which is essentially core set. So we split my training data into then three sets. One is my the CTAR set, essentially the unlearned set. The retain set essentially is two parts. One is all the course set, and another is all the in the embedding space, all the samples which are close to a particular this CTAR concept space. So using the embedding distance, we figure out which are the closely related concepts from my training data set. Okay, and that's what we call it as a fine-grained concepts for CTAR. Now, once you have fine-grained concepts of CTAR, you essentially figure out the top K matches, top K concepts with the highest similarity, and we call this top K matches as the adjacency set of CTAR or adjacency of CTAR. Right. So now we know that, okay, these are the concepts that needs to be retained as a fine-grained set, and the remaining concepts which are a little far away, they are called as the coarse-grained retained set. Okay. Now our objective is effectively unlearn the CTAR and also ensure that the retention of fine-grained and coarse-grained concepts should be there. Right. These are now two objectives in the machine learning objective. So for that, in order to achieve these two steps or two objectives, we have developed essentially three loss functions. The first one is the erasing loss function, which helps forgetting the this particular CTAR. Right. So the loss function, erasing loss function, forces the model to forget or do a gradient ascent on CTAR. The guidance loss is where we have to help the model to understand what is the distinction between the CTAR and adjacency of CTAR, right? The adjacency of the model concept that we want to forget. And the third one is adjacency loss itself, which tries to preserve the fine-grained concept. So what erasing loss does is try to be removed from the model space. Guidance loss essentially is like I mentioned earlier, right? That you have all the model, the previous algorithms were essentially trying to find a surrogate. So guidance loss essentially tries to look at no surrogate, particularly not from the adjacency matrix. Can we actually think of a surrogate as a null space in the model parameter space? So we essentially what we do is we take the average of all the concepts, including background and foreground concepts, as the null space. So we create a hole and replace this hole with respect to this null space or the average embedding of the entire model as the null space in the for that particular concept, right? And adjacency loss ensures that there is enough descent with respect to the adjacent matrix, as well as like from the far away concept in terms of the coarse grain set, right? So this essentially erasing loss and guidance loss ensures that we forget CTAR, and while not finding any surrogate, the surrogate essentially is the null space, and the adjacency loss essentially is trying to help retain the knowledge of fine grained as well as coarse grain. Okay. If I put all the things together, the very first step is doing the figuring out the concept neighborhood, right? And then this concept neighborhood is then we fade the particular the knowledge of a particular target concept while preserving adjacency set as well as the coarse set, right? And we use in the LoRa training for ensuring that we don't have to train from scratch, and the model is updated for a particular target concept only, right? Target concept unlearning only. Now, the next question, a very important question comes in: how to evaluate machine unlearning? Okay, so for this, there are the literature had actually two matrices. Again, I said, like, it's very new literature or very new field, therefore not very many work has been done. So what existing papers, few papers or 5-6 papers have been doing is they used erasing accuracy as a measure in terms of like how much we have forgotten, and then course retention accuracy as my other measure, how much we are able to preserve separately. What we actually said, actually looking at two different matrices may not be a good idea. We don't know how the performance is. In fact, I'll show you some results later. Some of the algorithms are very good at erasing, but they are also forgetting, right? What we said is there should be a balanced score and balanced metric where the information from both erasing and retention should be incorporated. And that's what we are proposing in ERB, where we are balancing between my erasing performance as well as retention performance as the harmonic mean of the two accuracies, erasing and adjacency accuracy. Okay, adjacency accuracy essentially is a retention accuracy. Now we, because this is the first paper on machine unlearning in fine-grained setting, we defined the protocol on Stanford dogs, flowers, Caltech, carb dataset, ImageNet, and I2P datasets, and so on and so forth. Right. By the way, ImageNet dataset and I2P dataset has been already used for coarse grain unlearning, and we are using the existing ones. The first 4 datasets are used for fine-grained unlearning, where we have defined the protocol. So here are the numbers. If I use only the retention accuracy or erasing accuracy, you could see that most of the algorithms are, at least some of the algorithms are able to achieve 100% forgetting accuracy. But at the same time, the retention accuracy is very poor, like 20% or even 2% and so on and so forth. And the ERB, while it's essentially it's a unbalanced performance evaluation if you look at both the matrices separately, and that's where ERB comes in the picture, which shows a balanced performance over all the concepts of forget set as well as the retention set. And you could see like ERB highlights that most of the existing algorithms struggle with respect to balancing between the two. Okay, and our proposed fine-grained algorithm, because the way we are trying to not find explicitly a surrogate and ensuring that the adjacency concepts are remembered, we are able to actually achieve good performance. Okay, and here are some more results with respect to the visualization of the results with respect to different data sets. Like we are able to preserve the dog, even the flowers, even the petals, and so on and so forth. And the last example you see, it's a beautiful example of blue jays. Means we can forget blue jays while remembering Florida jay and green jay and so on and so forth, right? These are more examples of on ImageNet dataset, and you can find all these samples, all these results in our paper, in CVPR paper. And this year in ICCV, we are doing this Gen challenge. The first challenge on concept unlearning in generative space. So if you would like to participate, deadline is still not gone. It's August 1st. So you can look at the details on Gen challenge website. Now, very quickly, I'll talk about, but before I go to the negation part in 5 minutes, are there any questions? Krishna, are there any questions?
There are a couple of questions. Hello, sir. Can you please explain the three losses once more with an example? I think maybe the CVPR paper, professor's paper is available. In the interest of time, you can, or you want to recap, sir?
So very quickly, means erasing loss essentially is trying to do gradient ascent on the particular CTAR concept. Guidance loss is essentially forcing the model to forget with respect to means when there is in the embedding space there is a space over there for a particular let's say English spaniels, right? So in place of removing that, you can't remove it, right, as it is. So existing model was trying to do the like surrogacy, right, for that. So what we are saying is that don't find a surrogate, create a null space of that particular. So null space essentially creating selective amnesia, and that's where like it's a simple loss. It's a L2 loss between the current concept, the concept that you're forgetting, minus the average embedding of the entire model, right? So that's what the guidance loss is, and adjacency loss is essentially doing the regularized gradient descent on the fine-grained concept that actually we talked about over here, like on the fine-grained concepts of CTAR, like adjacency of CTAR concepts, right? So these are essentially three. Look at the equation in the paper. Probably you'll be able to follow through them.
Okay. The next question is this notion of unlearning can be generalized to other modalities like audio, for instance?
Yes, in fact, we have a paper under review right now, which is on audio unlearning, forgetting an accent, forgetting a speaker, right? There are actually many things possible in audio. In fact, just wait for 2 more weeks. Probably we'll release the paper also through archive, and you can see like how we can achieve that in audio as well.
Okay. And one more question is how erasing is different from forgetting?
So they both are same. In fact, our title is erasure, not necessarily saying. So it's erasing, right? Means unlearning psychologically is very difficult process. So erasing is essentially a surrogate term of unlearning.
Okay. And another last question till now is does federated unlearning guarantee complete data erasure or can remains of deleted data still leak?
Can you repeat the question, Krishna?
Does the federated unlearning guarantee complete data erasure or can remnants of deleted data still leak?
Okay. So we are not deleting at a data level, right? This is at a model level. So data level removal has to happen at a data level, right? So this is at a model level. So like the question came in earlier, right? That how can we ensure that right to be forgotten is achieved at a model level? So if I say that remove my data from your data set, you can say, hey, I'm giving you a guarantee that we have deleted your data from the data set. But if a model has been trained, and I've already actually shown that model can regenerate the sample that it has been trained on. Now, if then therefore we need to ensure that if someone says that remove my data from your data set as well as model, that's where the erasure or the unlearning comes into the picture at the model level, right? And therefore, if you talk about federated unlearning at a data level, then the guarantee should come at the data level. We are talking here about guarantee or not guarantee, at least the hope in terms of at the model level.
Sure. So that addresses kind of the questions so far. So
Okay.
I think we can still spend 5 to 10 minutes, Professor, based on your planning.
Yeah. So I'll try to give the flavor of the next or related problem in 5 to 7 minutes time frame.
Mhm.
Now, if you see the second problem within this whole field of control Z for generative AI is negation. Another very important topic. In as like there we are explicitly saying that forget this particular concept. Now imagine we are not trying to forget the concept, but when we're generating, we don't want to generate a particular concept. How to do that? For example, if I say a car without tires, I want to generate car without tires, right? So what happens in DALI 3 or Mid Journey, while some of these samples that I have generated, they're slightly old, but and then I'll show you later on, even the next slide itself, the latest models that how they are doing. They're still able to, like in these examples, like a dog without does not have ears, they're creating a dog with ears, right? A car without tires, generating in fact one extra tire, and so on and so forth. So models are actually not able to understand how not to do things, right? In fact, if you see, when this is the sample set I created recently. This is for our NeurIPS submission. If you see, when in this we all play cricket, right? We all know cricket very well in India, and therefore I'll show the third example. If you see a cricket ground with unbowled overs where the stumps are unset and pitches are unmoved. The first example by GPT Image 1, the latest model that is over there, the stumps are set, the pitches are moved. Only the first concept, it did not generate. Whereas in the SDXL, the latest version of SDXL was able to actually even not even look at that part. There are players, the pitches are fine, like moved, as well as the stumps are set. And the next example, if you see a florist greenhouse with unarranged bouquet where the stems are untrimmed and the vases are unfilled, all three models, GPT, Grok, and SDXL, simply failed. Could not even understand we are talking about something not to be generated, right? So this is a related but a different problem statement in terms of when we are generating something, when we are explaining certain aspects, what not to look at or what not to actually use in a generation. A very classical example is with respect to doctors. I think I have an example here. Yeah. So if you explain a doctor, if you ask a doctor to explain the symptoms, and a doctor looks at your chest X-ray, doctor will actually talk about presence of certain symptoms, right? That okay, there are some these issues at this particular angle, that angles, effusion, small peripheral pleural effusion, and so on and so forth. The doctor will talk about certain symptoms that he or she would see. At the same time, doctor will also talk about what symptoms he or she is not able to see, right? In order to achieve a two particular decision of what the disease is. Like the doctor will say there is no evidence of a particular disease, or it would say that there is something which is uninvolved, absence of certain, let's say, bone fractures, or with no signs of certain things, right? So you may have seen like a report, even a ultrasound report or CT scan or whatever, right? You may have seen many reports which talks about many things which are yes, which are many things which are no, both affirmative and negative aspects of different symptoms. Now, if I ask actually a model to do this, model may not be able to generate these kinds of outputs, particularly when we talk about text to image models. If I give a, like I have shown you here, right, some samples over here, if I give a prompts which is mix of affirmative and negative symptoms, right, if I can use the word symptoms or attributes, then the model does not understand fully, like, and comprehend, have understanding in the image space. And that's where the problem of no is in the machine learning space or generative AI space. And these are again like ChatGPT 4o, Gemini, these are all actually give me, and then explain that even if you see Gemini and ChatGPT 4o both explain that these two dogs do not have ears, like completely wrong. In fact, since you have already seen, I don't want you to close your eyes anymore, but just if you try the prompt image of a chicken that is never frozen, Janus Mid Journey, and this morning Gemini's output is these three healthy chickens. Right? Whereas this is completely wrong in terms of negative prompts, right? And that's where like our research paper comes onto the picture in terms of defining the taxonomy of negation in a multimodal space. Like there are different kinds of negations, like syntactic negation, which are directly talking about a dog does not have ear, or even double negation like generate a painting, don't use the color red. Right, so we are saying that generate a painting, but don't use a particular color, particular attribute. right? Negative concord, even morphological or lexical ones, which are saying you are unhappy, right? So unhappy is a negative word, and whereas happy is a positive word, right? And the chicken example I already talked about, which is nothing but a negative polarity item. And we Indians are very good at non-verbal cues, saying something no, using non-verbal cues, non-written cues, probably non-verbal as well as audio cues to say something no over there. So in a true multimodal system, understanding negation in a grounded fashion where text, audio, and images, all three are well connected, is a very important phenomena. In fact, our archive paper presents this particular taxonomy in much detail. And this particular year in VACVI, we presented our work on ConClip and the data set related to that, which is CCNeg, which is a benchmark for evaluating VLMs on negation. So we created a data set with more than 228 samples derived from COCO data set. And while the positive concepts are already made available, we created a negative sets using Palm 2 with respect to every image, and created a triplet style of learning in Conclave, where we could do essentially three learnings. One is with respect to positive affirmative sentences, as well as the negative or negation understanding. With respect to this enforcing the clip model to understand negation sample also, we actually performed experiments, and we realized that while clip is not able to understand many negative sentences in the text to image space, originally with 65% performance, the conclip version, the updated loss function, which understands the third part of the triplet, which is a negation prompts, we could actually achieve more than 99% accuracy, like the huge jump on the test set of conclave on CCNEC data set. Similarly, when we did a zero shot setting on multiple data set like ImageNet, Caltech data sets, there also we realized that even if we change the backbone within the clip, like VIT with 16, 32, and 42 14 kind of architectures, consistently we could see the improvement that comes into the picture when we talk about training with respect to negative concepts as well. Right. So this is still the beginning of these two research pointers. We need to embrace these two concepts, machine unlearning, erasure, as well as negation, to truly say that yes, we are heading in the right direction for artificial general intelligence and a better usage of these LLMs and LVMs for applications like medical as well as biometric domains, to ensure that enhanced trustworthiness and ethical deployment is achieved. And I think the community needs to join the hands in terms of ensuring that more and more research should come in this particular area. And that's where I hope that some of you would get excited about these two problems and take forward. With that, thank you. Here is my coordinates with respect to reaching me out. And I acknowledge my students, collaborators, funding agencies who are supporting machine learning work has been supported through India AI mission. And some of my PhD students and collaborators from different companies are working jointly on these problem statements. Thank you, everyone, for listening to me. And if there are any questions,
Yeah, Professor. We are almost at the top of the hour, but there are two last queries that we could take. So one of the queries is, what if after unlearning a model, there is a need for it? Can we retrieve that data after unlearning too?
you can't. Okay, let me actually give a larger answer. In fact, CVPR itself, there are two papers which highlighted that most of the existing algorithms, not ours, but most of the existing algorithms, they have not essentially forgotten. They've just kind of suppressed that memory. So you can like do adversarial prompting to regenerate those samples. Having said that, we tried on adversarial samples. Our model is robust to most of the adversarial samples. But if you have to retrain, the knowledge of forgotten concept, the simplest way is just like do incremental learning on your foundation model on that particular concept itself, and it will be able to regenerate. But then again, like means this is a much open-ended question right now, like how to do incremental learning on a concept and not break the model itself. A lot of work has been happening on the incremental learning part, like self-supervised incremental learning papers are there. So that is completely possible. But this is a more ethical question in terms of that, do you really want to learn again an unlearned concept? What happened? What changed? Did you get a consent back? And then those questions also needs to be looked upon if you have to relearn a particular forgotten concept.
Okay. So another question is negation due to non-representative nature samples with the negation of the training data, or rather, can we say the generative models are not generalizing for negation?
So both. So actually, very good question. Think of this way. First of all, we have not given what do we mean by negation in terms of text to image grounding, right? So if a person is on the beach without dog, right? So it can be with a girlfriend, it can be alone, right? It can be with 1,000 other people. So the meaning of no is also very important to figure out, right? Or ensure that the models understand what do we mean. Negation is very important in general when we talk about like no years and so on and so forth. Those are like for motivating examples, simple examples to figure out. But the real application of negation is in the medical domain, in the agriculture domain, right? Means when we talk about different diseases for plants and so on and so forth, in security domain, there you have a particular peculiar meaning of negation, and therefore the grounding should happen with respect to the context and application. And that's how actually one can look at, and therefore there you need data as well as the context both in terms of ensuring that the negation is well understood. So it is one problem is certainly it's not generalized. Second problem is that it has not seen the context aware negation negative data.
Okay. So the last question probably is it still possible that the model could recall about the concept given some hints or guided chain of prompts?
Yes, and that's where like the adversarial prompting for machine learning has shown that the models can actually most of the existing models can recall like one example I can give you. So you take a celebrity's name, let's say for the sake of discussion, let's say Elon Musk, right? You forget Elon Musk from the model. Now, if you give a particular prompt which defines all the very close fine-grained features of Elon Musk, most likely you will get an image generated which looks very closely which will closely resemble Elon Musk, right? And because the name wise the person may have been forgotten, but then the attribute, you're not forgetting the attribute altogether. And that's where, like as I said, like our approach, because we went at the attribute level, like at a fine-grained level, we still need to figure out what could be the adversarial prompts where our model would fail. Probably means there will be certainly more adversarial prompts where our models will also fail. We can go into much finer details where adversarial prompts can be written. Right? As I said, it's a selective amnesia, and even for humans, at least in the Bollywood movies, selective like after prompting the memory can come back, right? So same actually is applicable in the large models as well. If you give enough prompts, if you give enough, if you jog the memory again, probably it can come back. It just like kind of suppressed. Most of the algorithms are just simply suppressing the memory somewhere.
Okay, yeah, sure. I think we are already over the time. And on behalf of ACM India and on behalf of the enthusiastic participants, we would like to thank our speaker, Professor Mayank, for a wonderful talk on machine learning and the concept of negation. Thank you, Professor.
Thank you, Krishna, for inviting, and thank you, participants, for joining in today.
Thank you.
Have a nice day.
Shall I end it?